efficient, right? But what if that very race for efficiency is actually making our systems dangerously fragile? Today, we're going to dig into how the way we scale AI is creating these hidden single points of failure, the kind that could impact all of us. So here's how we're going to break this down. First, we'll tackle the efficiency paradox, this idea that being efficient can actually be a problem. Then we'll trace how that efficiency concentrates power and creates these really fragile chains of dependency. After that, we'll look at how those chains can snap, leading to massive cascading failures. And finally, we'll ask the big question. If this risk is so huge, why is it so hard to see? All right, let's jump right in with something that might sound a little backwards, the efficiency paradox. We're always taught that standardizing things, reusing parts, that's what makes systems strong. But in the world of AI, it turns out that what seems like a really smart choice for one person or one company can end up creating a huge weakness for the entire system. And this right here, this is really the core of it. AI systems get big and powerful through reuse. It makes perfect sense, right? You build a great model, you reuse it. But here's the catch. Every time you reuse it, you're not just reusing the good stuff. You're also reusing and concentrating all the original decisions, all the hidden biases, and any potential flaws. You're basically amplifying them across the whole network. This slide just lays out that paradox perfectly. On the left, you see why everyone does it. For any single person, standardizing is a no-brainer. Performance gets better, it's easier to work with others, and you save money. But now look at what happens on the right when everyone makes that same logical choice. System-wide, diversity just collapses. Everyone becomes dependent on the same thing, and that resilience you get from having options, it gets stripped away. And that really gets to the heart of the trade-off, doesn't it? Our obsession with efficiency means we're constantly trying to cut out what looks like waste, what looks like redundancy. But here's the thing. In any complex system, that redundancy is resilience. It's the backup plan. It's the spare tire. It's what keeps the whole thing from crashing when one part fails. Okay, so how does this all happen? How does everything get so concentrated? Well, it's not by accident. It's driven by one of the most powerful forces in the entire tech world, network effects. You can kind of think of this process like a funnel. At the top, it's wide, lots of options. But then network effects kick in and start amplifying the most popular models. As more and more people jump on board, the funnel gets narrower. Alternatives start to fade away. Then it gets really hard and expensive to switch, and that locks everyone in. Before you know it, the entire ecosystem is being channeled down to a single point of dependency at the bottom. And this creates a really interesting state called functional centralization. Now, this isn't about one giant company controlling everything, like a monopoly. It's about function. Think about it. If you have thousands of totally separate companies all using the same AI model to, say, set prices, their decisions suddenly become linked. They're functionally centralized. And that means their risks are centralized too. So, this functional centralization starts to build these incredibly strong chains of dependency. Let's take a look at just how deep this goes, how foundational this AI infrastructure is actually becoming. What's happening is that these AI systems are moving upstream in the economy. They're not just another app anymore. They're becoming the core plumbing. They're making fundamental calls on things like pricing, how resources get allocated, how we assess risk. They're shaping the basic mechanics of how our economy works. And because this infrastructure is so far upstream, affecting so many different industries, a single mistake, a tiny bug, one bad piece of data, a flawed assumption buried deep in a model doesn't just cause a small problem. It scales instantly. The error just shoots downstream to literally everyone who depends on that system. Now, when you have an error that can spread that fast through all these dependencies, well, you've got the perfect recipe for what we're talking about next, cascading system failure. The very same things that make AI so amazing, its speed and its scale, are the exact same things that guarantee when it fails big. This slide really breaks down the 3 ingredients for a disaster. First, you've got decisions happening at an insane speed. Second, to make things even more efficient, we've removed the human checks and balances, the very people who could hit the brakes. When those 2 things combine, you get the third part, a failure that is so complex and tangled up that it's incredibly slow and painful to fix. It's a fast in, slow out kind of problem. And really, that's just the unavoidable truth here. The speed that makes these systems so valuable is the very same speed that makes them so risky. The velocity that creates the upside is exactly what multiplies the downside when things go wrong.
Okay, so if this is all so risky, you might be wondering, why aren't alarms going off everywhere? And that brings us to the final and maybe most subtle piece of this puzzle. The risk is invisible. It's building up silently, hidden behind all the day-to-day success.
A big part of the problem is that the tools we use to measure risk are just outdated. They're built for a different world. On the left, that's the old way of thinking. Everyone is independent, doing their own thing. But on the right, that's the reality with AI. This functional centralization connects everybody, so they start acting in similar ways. Their risks become correlated. But our old models just aren't built to see that hidden web. So what this really means is we're looking for danger in all the wrong places. We're looking for a single bad guy, a single point of failure. But the risk isn't a person or a company. The risk is the similarity itself. It's the fragility that emerges when millions of smart, logical, individual choices all add up to create one big, fragile monoculture. So where does this all leave us? Well, first, our system-wide resilience goes down. The whole network just has fewer ways to handle a shock. Second, our window to fix things shrinks. We have way less time to react before a small problem becomes a catastrophe. And third, who's to blame? Accountability gets incredibly fuzzy. In this giant, tangled web, it's almost impossible to point a finger when something goes wrong. And this brings us to the bottom line. Pushing for peak performance, for maximum optimization, creates systems that are incredibly powerful, yes, but also incredibly brittle. If we want a future that's truly robust, the answer isn't just better performance. It's architectural diversity. Real long-term stability is going to come from having lots of different approaches, not just from making one single approach perfect. Which leaves us with a pretty big question to think about, right? As these systems get woven deeper and deeper into our world, we have to ask ourselves, if every little bit of optimization we add also adds a tiny, invisible layer of fragility, what's the real cost of all this efficiency we're chasing? This channel explains money, artificial intelligence, and decision-making as interconnected systems. No hype, no gurus, no personal branding. New videos weekly.